Why are unsupervised learning clusters hard to interpret? Have you ever wondered why some data groupings seem to make sense while others leave us scratching our heads? When it comes to unsupervised learning, particularly clustering algorithms, the challenge of interpretation can be quite puzzling. Let's break down why these clusters can be tough to understand. Unsupervised learning is all about finding patterns in data without any labels to guide us. This means that when we use clustering algorithms, we are grouping data points based on their similarities, but we have no predefined categories to check against. This absence of labels makes it hard to know if the clusters we see are genuine patterns or just random results from the algorithm. One major factor is the lack of labels. Without labeled examples, we cannot determine if the clusters reflected real trends or if they are just artifacts created by the algorithm. This uncertainty can lead to confusion when trying to interpret what each cluster actually represents. Another challenge is the subjectivity involved in deciding how many clusters to create. The optimal number is often a matter of personal judgment. Choosing different numbers can lead to entirely different groupings, which complicates interpretation further. Clustering algorithms can also be sensitive to initial conditions. For example, in the k-means clustering method, the starting points can significantly affect the final clusters. This means that running the same algorithm multiple times can yield different results, making it hard to reproduce findings. High dimensionality adds another layer of complexity. When data has many features, it can be difficult to visualize and interpret clusters. Techniques to reduce dimensions can help, but they might also lose important details, making the clusters even harder to explain. Real-world data often includes noise and outliers. These can distort the boundaries of clusters, leading to misinterpretations. Additionally, some algorithms assume that clusters are simple shapes, like spheres. However, real data can form irregular shapes, complicating the assignment of clear meanings to clusters. Evaluating the quality of clusters is another hurdle. Without labels, it is tough to measure how well the clusters representing the data. Metrics like silhouette scores relying on distance measures that may not correspond with meaningful differences. These challenges highlight why interpreting unsupervised learning clusters requires careful thought. In applications like customer segmentation or anomaly detection, the difficulty of interpretation can lead to biased decisions if not handled properly. Tools like ChatGPT and image generators, such as DALL-E and Midjourney, incorporate machine learning models, including unsupervised components. However, the outputs often need human judgment to assign context and meaning. Ethically, the challenges in interpreting clusters reminded us to validate automated groupings. Misinterpretation can lead to incorrect conclusions, which is why understanding these limitations is essential for responsible use in artificial intelligence and productivity tools.